Welcome to this explainer. Today we're going to completely demystify how you give your Python programs the power to make decisions. You know, if you've ever wondered how a piece of software knows exactly what to do next based on what a user types in, well, you're in exactly the right place. We are starting from absolute scratch to teach you everything you need to know about Python conditional statements. Let's get right into it.
Here's our roadmap for today. 1. Making choices in Python. 2. Adding fallbacks with else. 3. Multiple conditions using elif. 4. Nested if statements explained. 5. Avoiding the indentation trap. And 6. Conditionals and operators recap.
So, before we even look at a single line of code, we've got to ask a really fundamental question. How does a computer actually make a choice? I mean, think about real life for a second. We are constantly making decisions based on changing conditions all around us, right? Your brain takes in inputs and outputs an action. Well, computers do the exact same thing. But they need us to explicitly spell out those conditions for them.
Think about it this way. If it's raining outside, you grab an umbrella. Python's conditional statements work the exact same way. They run specific chunks of code only when a certain condition is true. It basically gives our code the power to make choices, kind of like how a traffic light decides whether cars should go or stop based on the color it's currently showing. So in Python, if a user's age is 18 or older, then the program allows them to vote. Makes sense, right?
Section 1. Making choices in Python. The anatomy of if. Now, Python expects a very strict structure here. It always starts with the keyword if, followed by a condition that evaluates to either true or false. Then, you absolutely must end that line with a colon. Finally, the block of code that you actually want to run if the condition is true goes on the next line. And crucially, this is a big one. It must be indented.
This perfectly illustrates the logic in action. Imagine a bar chart crossing a target threshold to unlock a trophy. We're checking if a player's score has beaten the high score. If the score is, say, 1250, Python asks itself, is 1250 greater than 1000? True! So that indented code runs and prints new high score to congratulate them. It's incredibly straightforward and reads almost exactly like English.
Section 2. Adding fallbacks with else. The fork in the road.
But what happens if the score isn't high enough? We can't just leave our program hanging. To create a fork in the road, we first use comparison operators to ask those true or false questions. A double equals checks if values are identical, an exclamation mark and an equals checks if they are not equal, and of course, we have our standard greater than and less than symbols. These operators are literally the building blocks of your conditions.
So, when the answer to a comparison is a big no or false, the else statement steps in as a default fallback. It's a simple fork in the road. Does the user have the correct password? If yes, the path unlocks and they log in. Else, the path remains locked and we throw an error message. Notice that the else block never has a condition next to it. It's simply a catch-all for absolutely everything the if statement rejects.
Section 3. Multiple conditions using elif. Stringing possibilities together.
Sometimes a simple yes or no just isn't enough to get the job done. That's where elif comes in. The official Python documentation notes that elif, which is just short for else if, allows us to cleanly check multiple different conditions in a structured sequence. So if your initial if condition turns out to be false, your program doesn't just give up right there. It moves right on down to check the elif condition. And the coolest part? You can chain as many of these elif statements together as you need.
Let's look at how that chain works for assigning grades. I like to think of it like a ball bouncing down a set of stairs. Python starts at the very top. Is the score 90 or above? Nope. So it bounces down to the first elif. Is it 80 or above? Yes. It assigns a B. And here's the real magic of the structure. Just like that bouncing ball, once it lands on a true condition, Python executes that block and completely skips the rest of the stairs. It won't even bother checking the lower grades. Section 4. Nested if statements explained. Layering conditional logic.
Now let's see how this builds when one decision depends entirely on another. Think of nesting like trying to get to a treasure chest hidden inside a locked safe. You have to get through the outer door first. Here, the program only checks if attendance is high enough after confirming the marks are above 90. Notice that double indentation? That inner if statement is protected by the outer one. So if a student has marks of 80, the outer door stays firmly locked, and the program just bypasses that inner code entirely.
The absolutely crucial point here is that nesting helps you manage deeply layered logic. Take the e-commerce world, for example. You might first check if a purchase amount is over $1,000.
If it is, you dive into a nested if to check if that user is a premium member. If both things are true, boom, they get a 25% discount. If only the first is true, maybe they just get a 10% discount. Nesting is what allows for that really precise, step-by-step detail.
Section 5. Avoiding the indentation trap. Translating theory to practice. Okay, it's time for a quick reality check. As you start writing these statements, you are practically guaranteed to hit a very specific error. Unlike other languages that use curly brackets to group code, Python relies entirely on physical spacing. Because of this, a single unexpected space is literally like pulling the wrong block from a Jenga tower. It brings the whole thing crashing down in a fatal indentation error. If you accidentally mix tabs and spaces, or just plain forget to indent after your if condition, Python will straight up refuse to run your code.
Look, consider this error a total rite of passage for every absolute beginner. You are going to see it, and yeah, it's going to frustrate you at first, but to avoid it, simply stick to the standard. Use exactly 4 spaces for each indentation level. Honestly, the best way to save yourself this headache is to just use a modern code editor, like VS Code or PyCharm, because they'll actually manage all this spacing for you automatically.
Section 6. Conditionals and operators recap. The final synthesis. We have covered a ton of ground today, navigating from basic choices all the way to nested logic and error avoidance. So let's pull it all together. You can build incredibly robust decision trees by pairing what we've learned today with logical operators and, or, and not. Use and when both conditions must be true, like puzzle pieces locking together. You have to be over 18 and have a ticket. Use or when just one condition needs to be met. And use not, like flipping a toggle switch, to quickly reverse a true statement to a false one.
Mastering conditional logic is a massive leap forward in your programming journey. You have literally just given your Python code a brain, allowing it to make its own decisions based on the rules you set. But this leaves us with a really exciting question for next time. What if you want to run that if statement 1,000 times over? How do we tell Python to repeat these actions without typing them out over and over and over again? Well, that is exactly what we will tackle when we dive into loops. Keep experimenting with your conditional logic, and I will see you in the next explainer.